Hey guys, welcome back. Um, it's Saturday, and I went to the flea market again, and I found some things, but not as many, but a bit cooler in some ways. This is the second start actually, because it kind of took a turn for the worse. I have found something which I cannot take apart for the life of me, because none of my um not one of the sets of Allen keys that I have will actually fit in the bolts this damn thing has. So let's start with the first thing which I found, which is this. It's a very nice board with a giant photodiode on it. So quick rundown. We have this Centronic photodiode here. Two current feedback operational amplifiers, a high-speed comparator, a cable driver, and a good old 7805. So basically, in short, what I think this thing is you give it plus minus 15 volts here, because I traced the spin out to the negative of the VSS of the two operational amplifiers, and this pin I traced to the input of the 7805, and it probably gives you a pulse of electricity, obviously. It probably gives you a pulse corresponding to a pulse of laser light or any kind of light that this GAN photodiode feels senses. And it actually probably also gives you a pulse on this pin header right here, because the output is directly connected to the cable driver. I think it might actually be a differential pulse, so plus minus something volts. And the last pin is a ground. So when my power supply comes back from repairs, I'm gonna power this thing up, and I'm gonna try and smack it with some LED light and see what it can do. These ICs are both obsolete. They're older current feedback operational amplifiers from analog devices, and this is worth the entire trip. Just look at that photodiode. It's giant. The only bigger one I've seen was in Mike's video on that airplane laser guidance system or something, and the one he found in that thing was actually split into 4 quadrants. So yeah, that's the first thing I found. I'm gonna zoom out a bit, and next thing, well, the guy I get my parts from usually has quite a bit of surplus military tech. So these are a couple of, I think they're dash panel cockpit indicators for MiG-21 Lancers or other sorts of Soviet jet fighters. They might be from something else, but the thing that ticks them off is this one is specified to work at 400 Hertz. This is a V, and I don't know what else this is. So angular velocity, probably? I have no idea. Anyway, these are, I tried them out. I tried applying some DC current to them, thinking they might be microamp meters. Maybe I could make a cool clock of some description from them, but I think they're both entirely made for AC voltages, so I have no idea what these are. They're pretty cool, so yeah. I did try, an accent on try, I did try to take one apart, but they're very potted and very sealed, and I have no idea what to do to get any deeper in these things. And yeah, I suspected this was radium paint as well, but Geiger counter says nothing. So these are pretty safe. The third thing I found was this thing. I have no idea what brand it is, but I do know it's the only thing I've ever bought from the flea market, which when turned on it works immediately, and it's some sort of weird rubbish night vision. It's probably got a camera inside and some infrared LEDs, and yeah, it's pretty bad, but it's fun. And let me take it apart and see what's inside for you guys. That's a very high quality Chinese made screw. I'm expecting this to be a clamshell and just falling apart in 2 pieces because I don't want to invest too much effort in taking this thing apart nicely. Okay, so it's still turned on, so we can take this piece out and we can see there's a LCD display of some sort inside and a switch, on-off switch, and I think that's just about it. That's a camera that looked to my eye. Because I'm pretty damn sure that this thing doesn't have any idea of what high voltage or image intensifier tubes are or anything of the sorts. So yeah, pretty much what I suspected. A camera with a lens. This is how you actually focus the thing as well. And we can see the sensor inside just if you wait a second. That is tiny. It is one of the smallest image sensors I've ever seen. And it's feeding straight into this LCD. And that's all. This is really stupid. It's like, it's supposed to be like a telephoto lens, like night vision binoculars. Just the amount of stuff coming from the great outdoors markets. Like, this is crazy. And I don't know what this was when it was new, but I paid a little over €1 or the equivalent basically for this thing. So yeah, fun, but this is the battery pack. Fun, but completely worthless. Maybe for, I don't know, reverse engineering and using a thermal camera or something, I have no idea, but it's pretty much worthless. Like chip on board with a blob of epoxy, and yeah, again, the smallest image sensor I've ever seen. The resolution is terrible. It's like something along the lines of 200 lines or something like that. It's completely and utter rubbish, but it's still interesting that they actually went to the effort of making something like this. I don't know who the target market is or anything about who would ever want something like this. Okay, and the last thing, which actually caused me the most amount of trouble, is this thing, which I have no idea what it is. I am assuming it's a laser projector of some description, basing that claim only on the fact that I can see 3 laser diodes in here. So this thing used to be in a big black box. I don't have the box around because it was just messy plastic. It had this lens on the front, and it had a motor spinning this optics assembly here around. So this is a prism, which probably takes the light from the lasers and spins it around, I don't know, or takes, it's basically, it's like a right angle, and the prism is meant to reflect the light that shines in from here outside. And this lens was in front of it like this. So every time it did a sweep, I think that the light coming from the lasers hit this, bounced 90 degrees, and was projected through this lens, which is actually quite nice. It's a very nice lens, very good quality glass, I'm assuming, but I have no idea what this thing is. And the reason why I started this video the second time was because for the life of me, I cannot figure out what size these screws are. So they don't fit my imperial set, they don't fit my metric set, they don't fit anything, and my only chance is actually to try and take a pair of pliers to them. So I'll try that and be back, but in the meantime, some interesting notes. So there's a couple of heaters in here, in this block. One is here, and I remember seeing another one somewhere, but anyway. Lasers have pretty big coefficient of temperature, so their IV curve kind of changes with temperature a lot. So this whole assembly was thermally regulated by the PCB controlling it. I'll show you that in a second. And this is machined steel. Like the whole thing is CNC steel. You can see the this is where the end mill was, and it's actually incredibly intricate for, like, I'm assuming this wasn't a piece of consumer equipment, and it's very, very, very heavy. I have no idea. There's a beautiful lens in here, which I'm not entirely sure what it does, and it says laser aperture. Yeah, made by Agfa, and I shall look this part number up, but I'm not entirely sure what it is or if I'll get any useful information out of it. So yeah, you can see the heater in here, and there's the remainder of the thermal paste that coupled a temperature sensor actually to this assembly. The PCB, which was responsible for controlling this whole thing, is here. And this is a voltage reference, I'm pretty sure. I recognize this part number. This is a Darlington driver, actually a Darlington transistor array. 339 should be a comparator, and TL084 is this should be a quad operational amplifier. And this is a transistor responsible for the heater I was telling you about. So I'm pretty sure that this whole board is meant to control the temperature of that assembly. This is the PTC, or actually it's an AD592, so it's probably a temperature sensor. I'll insert the link of what it is, or a picture of the sensor, whatever I find this thing is. And this was thermally coupled to the rest of the assembly. So yeah, I have no idea what this thing was. There's a thing marked SW1, so switch 1 here. I have no idea what this is, apart from what I suspect is that it's a over temperature sensor. In case that everything goes wrong, this thing might trip and decouple the heater from the heater circuit. And AD586 is supposed to be, if I recall correctly, a 10 volt voltage reference. So yeah, a couple of 10-to-1 caps, connections for the heater, obviously big fat traces to the heater transistor, this is an N-channel MOSFET, and this was connecting to the rest of the harness. It wasn't actually going to anything on the diodes or anything like that. So this must have been just power input for the whole circuit, and this was connecting to the photodiodes, but I'm assuming it was actually connecting to temperature sensors on them or something like that. I have no idea if laser diodes have temperature sensors, or if it was an actual heater or anything like that, but I'll be able to tell you more once I crack the rest of this giant thing open. So let me get started on that. and I'll be back when I have it in a bit more pieces than it already is, because I told you, for the life of me, none of my Allen keys will fit in these things. I don't know what they are. And I have both metric and imperial sets, so maybe some weird standard I've never heard of. So after a lot of percussive maintenance and swearing and using the lathe chuck for, let's say, not exactly its intended purpose, I managed to extract the three main parts from that whole assembly I showed you earlier. So we have three laser diodes, one of which didn't make it out intact. You're gonna see some video of it under the microscope. But these are all the same. They're quite large infrared laser diodes. I found some information about them on the internet, and they're apparently 1,000 milliwatt each. So all of them are working, and they have the monitor photodiodes inside as well. And these were connected to some very interesting sockets. Actually, not the sockets, but the cables running through them were coaxes. So both the monitor photodiode and the LED itself, the laser diode itself, were connected through coaxes. So that actually makes me think that these were driven in pulses, very sharp pulses, and the monitor photodiode was sampled in the same way. These were fed into this wacky wavy prism. So basically this is like 3 prisms in one. 2 of the laser diodes were shining in perpendicularly to the main axis, to the main face. The other one was here, and this photodiode, which is very similar to the other one I showed you on that circuit board earlier, was mounted like this, and this was completely broken. Somebody tried to resolder it, and they did a very poor job of this, and it was probably the reason why this thing was chucked out. So after thinking a while, I've come to the conclusion that probably this thing was actually a rangefinder, or a laser rangefinder, actually, something along those lines, because I'm assuming that it's either that or a LiDAR, but like a 360-degree LiDAR, because on the output of the prism there was this thing, and it's not going to fit in the frame, just a second. So this thing was like this, mounted on the motor. It was spinning, and it directed the laser outside into a circle, basically, around it. So, and considering the fact that it would fire a laser pulse from here, shoot it through the prism, through the lens, and bounce it off whatever object it was trying to measure the distance to. The measurement would have been done by the time of flight, basically, or the time between when this laser is activated and the photodiode receives the signal back. What I don't understand, I have no idea about the functionality of this thing, is why there were 3 laser diodes, because these were all the same wavelength. So they're all matched. There were some numbers written on them, which tells me they were probably matched for wavelength. And they're all the same wavelength, so they're infrared photodiodes. I have no idea what's going on here. If anybody knows more, please feel free to correct me in the comments. And yeah, some nice pieces of optics. Oh, by the way, getting these things out was a nightmare. First of all, the Allen screws that were holding all of these things together were non-standard. So one of them was 3.6 millimeters, which is 150 thou in inches, but I don't know if that's a standardized Allen wrench. And these were held in a very weird collet, which allowed them to be aligned axially, like on a they could move at an angle regarding their center, so they could pivot around their center like this. So I'm assuming that's for being calibrated at the factory and making sure they all point as perpendicular to each other as possible. But I have no idea why it was made like this and why there's 3 of them and why it couldn't have worked with just one laser. Because ordinarily you'd have a, like from what I've seen in other LiDARs, you have a simple prism, a photodiode perpendicular to it, and the same arrangement with a moving mirror or prism. So you don't need 3. I don't know why there are 3 of them. I might be wrong about being the same wavelength, but the one I tested, which is this one, is infrared. So the phone picked it up. I couldn't see it with my bare eye when I powered it up with a few milliamps, but the phone saw the correct characteristic purple glow of the infrared diode. So yeah, as I was saying about this PCB, I managed to extract this heater element. So as you can see, this is an actual heater made by Hot Watt. It's a 6 ohm heater. I'm not entirely sure about the power, but it seems pretty beefy. Like, I think you'd be able to boil a cup of water with this thing. And it's got those fiberglass weave on the legs and the ceramic potting inside. And yeah, this whole thing, this whole board was basically charged with maintaining the temperature of the laser enclosure. So that entire piece of metal with the 3 laser diodes and the optics inside was kept at a constant temperature by this circuit. The sensor they were using for the temperature control was an Analog Devices 8592. I'm going to put it in the comments. I'm going to link the datasheet. It's apparently a high pre-calibrated accuracy, 0.5 degrees C max, and 0.15 degrees linearity from 0 to 70 degrees. So basically they wanted to keep it at a constant temperature around 20 something degrees, I'm assuming. And that's where they were most interested in what was going on. This 8586, I'm assuming, is the voltage reference. Usually these voltage reference have much better temperature coefficients than the lasers themselves. So it's not a 10 volt, it's a 5 volt reference, plus 2, minus 2 millivolts, and basic accuracy, and 2 ppm per degree C, which is pretty good, and it's a low noise one as well. So yeah, this generates a known 5 volts. This is the sensor for the temperature control loop. This is the driver for the heater. As you can see, there are 2 very pretty beefy high current tracks going here. This was the input connector for the power, and this was connected somewhere, I have no idea where. So basically I think it was just monitoring or input power, it looks like, and yeah. So that's about it for this thing. There's one more thing I'd like you to see, and I'm gonna have to pause a bit and come back with the other thing. So the last thing I got was this stupid thing. It's a Sony Video 8 camera camcorder, whatever. And you'd think, why the hell would I get something like this? Well, there is one simple reason. You know the Pip-Boy? Well, the Pip-Boy uses CRT display in the Fallout lore. It uses a green CRT. And I got the idea at some point to make a CRT clock using actual CRTs, but not as you might think. I want to make a CRT clock with 1 display per digit, and these cameras used to have not LCDs because they weren't that good yet, they used to have these viewfinders, which are composite video, actual small TV screens. So I'm going to take this apart and I'm going to talk to you about it. And I actually have two more. So I only need another one for the last digit, because I want to have a clock that goes like 2347 or something like that. And I'm going to have one digit per display. So give me a moment, I'm going to take this thing apart and I'm going to show you what's inside. Alright, so this is the viewfinder basically in its entirety. So as you can see, it's an actual small CRT monitor basically. We have the high voltage power supply feeding this, and this is the anode, which is the acceleration voltage. We have a small yoke, which is very nice. This is very cute. The whole thing is very cute. We have a mu metal shield, and you think that you remember the controls of usual TVs, which were the position and horizontal and vertical position. Usually those are done electrostatically, or actually electromagnetically, but it's far too complex to design such a control system for such a small space. Like, they barely have enough room for the blanking and the whatever they need to make one of these things work, like the raster generator and the blanking. So what I actually do is they have two magnetic rings which are polarized, and they're set at the factory so as the beam, when the beam is in the center of the image, they tune this to be whatever they want it to be. So the beam might be off to one side, and by tuning these two rings, you can see they're sealed with this glue here. By tuning these two rings, they can get the beam to align in the middle of the picture tube. So this is the yokes basically, and they're driven by this IC here, I'm assuming, as everything else is. This is the I think they're running on around 5,000 or 6,000 volts or something like that, because they couldn't get much more into such a small space. So I have this one now, and I actually have another two, which I extracted from similar camcorders. I'm pretty sure that they're exactly the same picture tube, because you can see these two are identical. The circuitry is a bit different on these ones. But, oh, and I also took out the plastic shroud here from the front on this one, because I didn't need it. But this is how I found out about the whole yoke thing. Also, moving the thing down, so you can see that for this one, the yoke is quite basically up to the top of the tube here. If you move it down, you can get a bigger picture, and then if you screw around with the controls on the back, you can tune it back in focus as you wanted it from the factory, as they did at the factory. So I'm gonna have to do the same thing I did with this one, which is trace out the 3 wires I need to connect it. One of them is around 9 volts power, the other one is ground, and the remaining one is composite video. These always run on composite video. So this is the same case for this one. You can see we have the yoke, the high voltage supply, basically the same IC for the raster generator and the miscellaneous components. The other device, the other board, has a bit more SMD stuff on it. And this one I think is about the oldest, because it has mostly through-hole components. And these two are the synchronization and the brightness controls. So one of them basically is locking the... If you go too far on one of these, it basically doesn't draw a picture anymore. So you can actually use this to synchronize the image better with the frequency of the composite video you're feeding it. I think it's to allow for PAL or NTSC, so they can have both PAL and NTSC camcorders sold in different parts of the world, but they don't need to make vast changes in the circuitry. They just need to tune this potentiometer a bit according to the signal they're putting in. So yeah, that's about it. I'm not going to tear down the camera for you guys, because, well, video cameras are pretty boring. And yeah, that's about it. I hope you liked the mixed bag I got for you today, and as always, thanks for watching.